Hi ladies and gentlemen, here's a little bit of help for your free body diagram practice. So this assignment suggests using a shortcut, a trick called the parallelogram method. Where this comes from is it's actually sort of doing vector subtraction, which is not something that we are going to work on in STEM physics, but we can use sort of a trick to help us do that without needing to do the complex math that goes along with it. So here's the basic steps. So first thing that you're going to do every single time, we're going to label the weight, the force of gravity acting on the object. We're going to use a ruler to draw a line that's equal in length and in the opposite direction of the weight. I've chosen to call that the anti-gravity line. Third, we're going to use a ruler to draw parallel lines. So lines in the same direction but not touching. If it's strings, they'll be parallel to the strings. If we have an object resting on a surface or interacting with more than one surface, we'll need to draw lines that are parallel and perpendicular to the surface. And where should we start drawing these lines? At the anti-gravity line. So we'll demonstrate that. And then the last thing that we'll do is we'll draw and label the other forces. If we want to determine what direction those forces are acting in, you have to use your brain. Don't just label every little line you see. And then the length of those force vectors, those lines showing force, will be from the center of mass to where our lines we previously drew intersect, the corners of this imaginary parallelogram. So let's go ahead and do some as an example here. Okay, I'm actually going to do one of these, number 4 and number 5 down here for my first examples, okay? So let's do number 4, and I'm going to zoom in on it, you know, in super dramatic and accurate ways, and I'm going to put my instructions up to the side. So first thing I'm going to do is I'm going to label the weight, the force of gravity acting on this object. For this, it doesn't matter what it is. I'm going to start at the center of mass. I'm going to label the force of gravity acting downward. My second step, I'm going to draw a line that's equal in length and in the opposite direction of the weight. I'm going to call this the anti-gravity line. So I'm going to draw an anti-gravity line here. I'm going to use my ruler to do that, and I'm also going to use my pencil. So I'm actually going to measure how long this line is. It looks like I've got a 1/2 inch, and over here we've got another 1/8, so I'm going to go up a 1/2 inch up to another 1/8. So that's my line that I'm drawing there. Can you see that on? So that line is in the same direction and the same length as the force of gravity, just going up instead of going down. So now my third step, I'm going to draw parallel lines. Again, I'm going to use my ruler, and this is an example with strings, so I'm going to draw lines that are parallel to the strings. So that means I'm going to line up my ruler with the string and then keep my ruler in that orientation no matter where I go on the page, so that no matter what I'm doing, that line is in the same direction as my string. And I'm going to start at the anti-gravity line. Is where I'm going to start to draw that. So I'm lining up my parallel line here. Like that. I'll do the same thing for my other string. Line up my straight edge. Go up there. I like using a protractor because it's clear and it has that guideline on it. Right, so now I've got these. And you can see here, this is why it's called the parallelogram method. I've got these sides. If I were to shade in this area right here, I've made a parallelogram, a quadrilateral with two opposite sides that are parallel to each other. So now I'm going to draw and label the other forces. They're going to go in the directions that make sense. I have to use my brain, and then the length of them is going to be given to me by the intersection of these dashed lines I drew. In other words, I'm going to draw my other force lines to the corners of my parallelogram. So, do I have a force up? a normal force? Nope, because this is not resting on a surface. This is hanging in the air, I would assume. Okay? So, but I do have these two strings that are providing the force that are holding this rock up from the ground. So I'm going to draw one of them, and I'll draw it up here to the corner of my parallelogram, and the other one over here. I'm going to label this force of tension for string number 1. And if this is string number 2, I'll label this force of tension from string 2. The label is totally up to you, but you can follow my lead if you want. All right, let's do the same thing for this number 5. Okay, and then we'll do one more on a surface. So, step 1, I'm going to label the weight. I have found that the bigger I draw it on this paper, the easier it is for me. So there's my force of gravity. Second, I'm going to draw a line with my pencil and my ruler, equal in length and in the opposite direction as my force. So I'm actually going to measure it. Oh, it's about the same length this time. How nice. So I'm going to go up. Okay, so there's my opposite, my force. Third step, that anti-gravity line there, I'm going to draw parallel lines. These are strings again, so I'm going to go parallel to the strings, starting at the top of my anti-gravity line. Parallel to the other string, starting at the top of my anti-gravity line. That one's really close this time. So you can see now I have a very different shape parallelogram. You can even shade that in if it helps you sort of see what we're talking about for a parallelogram. And now I'm going to label my other forces. Is there a normal force? No, it's not resting on a surface. It is, however, being held up by two different strings. So the tension in those strings is supporting the weight of the rock. So I'm going to draw this one up to the corner where those lines intersect with the string. This one barely goes off the string, so it's a very small arrow. So that's my force of tension for string number 1, my force of tension for string number 2. When you have situations like this where you have a parallel surface, that's a lot easier to figure out. Some of these others where they're at angles are more complicated. You have to actually use that parallelogram method. When you have a totally vertical or horizontal situation, you often don't need to use it because you already are existing in a pretty easy to see plane. Let's do number 3 as an example together as well. Okay, so this one isn't a string example. I'm going to follow the same process though. First thing I'm going to do is I'm going to label my weight. I'm going to make it big just because I can. There's my force of gravity. Second thing I'm going to do, I'm going to use my pencil and my ruler to draw my anti-gravity line. So it's got to be the same length. Ooh, I did almost a whole inch. One notch off from an inch here. So this time, my line goes way up here, almost to the top of the box. That's just how I drew mine. So you can see there's the tip of mine right there. Okay, so it's my anti-gravity line. My third step, since this is surfaces, I'm going to need to draw lines parallel to the surface and lines perpendicular to the surface. So I'm going to start with my parallel lines. So I'm going to line up my straight edge here. I'm going to draw one through the center of my mass here. Because I know I'm going to draw my forces through those. And then I'm going to draw my other one, again, parallel. Sound effects help me do things. Up here at the top of my anti-gravity line. So there's my two parallel lines that are parallel to the surface. Now I need to draw a lines perpendicular to the surface. Same thing though, I'm going to start at the anti-gravity line. So I'm going to draw, I want things at a 90-degree angle here. So I'm going to line that up like this. And I want to start at the anti-gravity line. So I'm actually going to turn my protractor and draw it upside down. Because I want to start here. I want to go in a 90-degree angle, so I'm going to look for 90 on my protractor. So I'm going to shoot for over here. I'll line up my protractor to get that angle just right. Okay, so that's how I do that. So you might be asking yourself, where is our parallelogram in this picture? I know I would be asking that. Well, we sort of have an invisible one where we've got the other line that would be coming out of our rock right here. So that's our other perpendicular line that we have. So this is a parallelogram that's a rectangle. Check with your math knowledge. That works. Don't you love geometry? So there's my parallelogram. So step 3, I'm going to draw and label the forces. So this is where you have to use your brain a lot more sometimes because we have to figure out what's happening. This says the force of friction prevents sliding. So this is an object at rest. That means that it's also in equilibrium. All of the forces are balanced and canceling each other out. So this is resting on a surface, so I know I have a normal force, but my normal force is always at a right angle to the surface. This line that's perpendicular to our surface and goes up to this corner of our parallelogram, that's our normal force. The force of friction prevents sliding. So if this was just let go and there was no friction, it would slide that way. So it would slide this way. But because we have no friction, this is not sliding. Or because we do have friction, it's not sliding. So that means the force of friction is in the opposite direction and parallel to the surface, which is from this center mass to this corner of our parallelogram. Does that make sense? Hopefully that helps you understand how to do a couple of these. Remember, the key steps are to first have your pencil and your ruler handy, and every time start by labeling the weight first. Start by labeling your weight, the force of gravity, then draw an anti-gravity line that's equal in length and in the opposite direction as the weight. Then draw parallel lines. If they're strings, make them parallel to the strings, starting at the anti-gravity line. If they're surfaces, draw parallel lines to the surface and perpendicular lines to the surface, starting and being guided by that anti-gravity line. The fourth step is to draw and label the other forces. Remember to use your brain to think about what forces are there. Just because there's dashed lines doesn't mean you have to draw a force. And the magnitude of those lines is going to be using those intersections of the anti-gravity and the side lines you drew, or another way, the corners of your parallelogram. Hope that helps. Good luck, everybody.